Okay, we've now taken derivatives of parametric equations. It's now time to get a little bit higher order. At the end of this lesson, you'll be able to take a higher order derivative of a set of parametric equations. All right, so higher order derivative, you'll notice, to get the second derivative, remember it's the way that we write that would be d squared y over dx squared, which is basically the derivative with respect to x of dy dx. So the way that we're going to do this is we're going to take the derivative with respect to time of dy dx and divide it by dx dt. So let's put that into plain English right here for you. The second derivative is the derivative of the first derivative, just like we're used to, but we will need to divide it by the derivative of the x equation. So that's going to be our extra step when we actually take the second derivative on these ones. So let's try one. It says for the curve given by x equals square root t and y equals 1/4 t squared minus 4, for t is greater than or equal to 0, find the second derivative when t equals 4. And then it says to also discuss the concavity. So we will do that too. We'll do this, and then we'll discuss the concavity. All right, so to get the first derivative, if you recall, we'll find the derivative of the y value, the y equation, and divide it by the derivative of the x equation. So when we do that, the derivative of the y equation, I'm going to distribute that. I'm going to get 1/4 t squared minus 1. So when I take the derivative of that, that will be 1/2 t. And then down below, when we take the derivative of this, this will be t to the 1/2. The derivative of that is 1/2 t to the negative 1/2. So this will equal 1/2 t over 1/2 square root t. And I'm going to just rewrite, first of all, 1/2 divided by 1/2. Those are just going to cancel out. So, whoops, this is a t down here. So I'm basically going to have t over 1 over the square root of t. And so I'm going to multiply by the reciprocal. So I'm going to get t over 1 times the square root of t over 1. And if you recall, t square root of t is just t to the 1/2. So t to the 1 times t to the 1/2 will add our exponents, and you will get t to the 3/2. Right, it did ask us to find, oh, that was just the first derivative. Okay, getting that second derivative now. We're going to take the derivative of the first derivative. So we're going to take the derivative of t to the 3/2. That will be 3/2 t to the 1/2. And then we're going to divide it by the derivative of the x value. And we found that the derivative of the x value was 1/2 t to the negative 1/2. Okay, so now from here, we are going to divide. 3/2 divided by 1/2 would be 3. And then this, we can, since the t's both have the same base, we can subtract the exponents, and I'll just get t to the 1. And so that is my second derivative. And then it also said to discuss the concavity at this point. So the second derivative at, it says find second derivative at 4. At 4 is going to be 3 times 4, which will be 12. Okay, so we found the second derivative, and then it says to discuss the concavity. Since we got a positive answer, we can say that the function is concave up. Function is concave up, and I can simply say because the second derivative is positive. And just a comment up here, instead of going through all this silly stuff right here, I just as easily could have subtracted my exponents right here and gotten t to the 3/2. So just a little FYI on that. All right, example 6, it says to find the concavity of x equals square root t, y equals 3t minus 1 at t equals 1. So pretty similar problem, I think. So to find the concavity, we are going to have to find the second derivative. So first of all, finding the first derivative is the derivative of the y value, which is 3. And then the derivative of the x value, we've taken this several times now. It's going to be 1/2 square root t. So if I multiply by the reciprocal, it's going to be 3 times 2 square root t over 1, which is equal to 6 square root t. And then from here, we are going to do, and actually I think to make this easier, I'll write it 6t to the 1/2. It's going to make it easier in the end. To get the second derivative, we are going to take the derivative of what we just got, which will be, since I rewrote it like that, it's going to be easier. I'll get 3t to the negative 1/2, and then divided by the derivative of the x value was 1/2 t to the negative 1/2. And so from here, I'm going to do this the shorter way this time. 3 divided by 1/2 will be 6. And then here we can subtract the exponents since my bases are the same. So negative 1/2 plus 1/2 would actually give me t to the 0, which is just 1. So my second derivative is just 6. And since I got a positive value, it says to discuss the concavity, I can say the function is concave up. And once again, that's because the second derivative is positive. And there we go. So hopefully now you can take some higher order derivatives of parametric equations.